Hello everyone. Today let's solve the problem number 460 LFU cache, right? LFU cache is also known as least frequently used cache, right? So what the question states here, we have to design an LFU cache, right? So let's see what is least frequently used this one cache first. So let me click on this one. So here you can clearly see this one. LFU is a type of cache algorithm that is used to manage memory within a computer. The standard characteristics of this method involves the system keeping the track of number of times a block is referenced in a memory. When the cache is full and requires more room, the system will purge the item with the lowest reference frequency. You can clearly see here, right? When the cache is full and requires more room, the system will purge the item with the lowest reference frequency. Purge in the sense evict, right? Evict or delete. So here in this case, LFU is sometimes combined with the least recently used algorithm and also called as LRFU, right? Nothing but least recently used algorithm. This one frequently used, least recently frequently used, right? So this is fine. So I hope this part is completely clear, right? So I hope now you know or now you have the understanding of what is LFU, right? So we have to design an LFU with, just give me a second here, with these things, get and put operations, right? So get consists of this one, what do you call, the parameter key, and put comes with the parameter key as well as value, right? So we have to design an LFU cache with get key, this one, get method, which returns the value if it exists. So we have to return the value only if it exists, else if the value doesn't exist we have to return -1. So the return value of the get is integer. The return value of the get is integer, so just keep this in mind. So the return value of the initialization or the LFU cache, and along with the put, this one along with the put, so for these two, the return value is null. Return value is null. Basically we don't have the return value for this one. Initialization will be null, quite obviously, and for the put, no. We just have to insert or update the key here using the put, right? So here we need to return the value. We have to return the value based on the key. So here in this case we have to return the value that is integer, else if the value doesn't exist we'll be returning -1. So here we don't have to return anything, so we have to insert or update the key. In this case we have to go with the return value null, right? So again I have said the same thing here. Again the return value is null. So when LFU is full means list, this one frequently used cache we are making use of, right? When this thing is full, when memory is full, we have to evict the least frequently used key. When this one, what do we call, when the memory is full we have to evict the least frequently used key. Least frequently used, nothing but LFU key. When the memory is full we have to evict or delete the least frequently used key, right? If a tie on frequency, then evict the least recently used among them. So if there is a tie on frequency, means same, this one, if we have the same frequency or if we have a tie on the frequency, then we have to evict or delete the least recently used among them. So the final thing is all the operations must run in big O of 1 average time. So this one also they have mentioned clearly. So all the operations has to, this one, run in big of 1 average time. Now you have already guessed that we'll be solving this one using the linked list, as they have mentioned strictly that all operations must run in big of 1 average time, right? So if you have guessed that one, yes, we will be making use of the linked list for this, basically doubly linked list, right? So here I hope the question is completely clear, man. We have to just go with the two methods. One is get and put. So the return value of put and initialization part is null, and only the this one, return value of the get is either the value integer, this one value, the integer, or it may be -1. If we don't have the value, then we have to return -1, right? So I hope this part is completely clear. Now let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. Let's discuss the this one, first one, approach followed by the complexities, and then let's write the code, right? So let me do one thing. Let's discuss this one by one. Let's consider the first example. They have given only one example. Let's consider the same for the approach, right? So that we understand this one clearly. So here in this case we have LFU cache of 2. LFU cache of 2, right? So here memory is 2, right? So memory is 2 here. So the output will be null because the return value of LRU cache or the this one initialization part, this one is, we know that this is null. Next, let's move on with the next one, nothing but put here. Put of 1 comma 1 we have. Put of 1 comma 1 we have. What we will do, we will insert 1. We will insert 1, right? So put of 1 comma 1, we will insert 1. So now this one we are having the frequency 1. We are having the frequency 1, right? So again, the return value of the this one, what do we call, put operation is null. This one, right? Only the return value of the get is integer, or if we don't get the value, then we have to go with the -1, right? So here again null. So next, let's go with the next put operation 2 comma 2. So now we have to insert 2 again. Cache consists of now 2 and 1. Cache consists of, now we have inserted 2. Next step, previous step, it consisted of 1 and the frequency is 1 as well, right? So here in this case, frequency is this one. Frequency of 1 is 2. Frequency of 1 is 2. Now frequency of 1 is 2 and the cache consists of 1 uh, F2 and 2 F1. To F1, right? So this one I'm speaking of, sorry, I got confused here. So we have inserted 2. Now the frequency is 1. Frequency is 1, cache is 2 comma 1. Now we have the get operation here. Get of 1. Get of 1. We need to return 1. We need to return 1. So here we have frequency of 1 equals 2, right? Frequency of 1 equals 2. See here, once, twice, right? So frequency of 1 equals 2. So this one here frequency is 1. Previous step frequency was the 1, not 2, basically, right? So we are going with a get of 1 and so so previously we went with put, right? So this is fine. Now we are going with get of 1. Get of 1, we have the frequency 2, but we have to return the value 1. We are having this one in the cache, so we will return 1, right? So now we have we have successfully returned the value 1. So this is fine. Next, let's move on with the put operation. Now we have 3 comma 3. 3 comma 3, right? So we are having the memory 2. We are having memory only 2 basically, right? So memory we have been given here 2. So now we have to evict 2. We have to evict the 2, right? So we have 2 comma 1, 2 comma 1, and we have to delete this one because adding, we cannot add the 3 because we have only the space 2 here. To add 3 we have to delete any number based on the LFU, least frequently used, uh, right? So least frequently used. So we have to evict 2 here or delete 2 and insert 3 and insert 3, right? So this one least frequently used is this one 2, and we will be going with this one 3 comma 1. So we will insert 3 in that place. Now we have 3 comma 1. Now we have 3 comma 1, right? So here in this case again the return value of the put operation, we know that this is null, right? So this is fine. We have completed with the put operation. Now let's go with the get again here. Get of 2 we have. Get of 2 we have. Previously we have deleted the 2. Now the cache consists of 3 comma 1. 2 is not present at all, right? So value, if the key is not present, if the key is not present here in this case, the value 2 is not present, right? Now in that case we have to return -1 accordingly with the question, right? So here in this case we don't have to, so we will be returning -1. We will be returning -1. So here in this case we have got the output -1. Next, let's move on with the get operation. Here we have 3. We have 3, right? So we have 3 here. See, previous step we have got -1, but we have 3 in the cache. We have 3 in the cache, so we can get the this one. will try getting the 3. So we have got the output 3 here. This is fine, right? So next let's move on with the put. Now let's move on with the put here. So put of 4 comma 4, right? So here we have put of 4 comma 4. Now we have tie. Basically we have tie, nothing but the 3 and 1, both are having the frequency 2, both are having this one frequency 2. Now we are having a tie, so we will delete one, we will delete one because least recently used among this one, what do we call, uh, among frequency 2 is 1. So in this case, instead of deleting the 1, we will delete, instead of deleting the 3, we will delete the 1, right? So least recently used is 1 basically. So we will remove this one and we will insert 4 in the place of 1. So now this becomes 3 comma 4, 3 comma 4, right? So 3 comma 4. Again, the this one, the return value of the put is null, right? So the return value of the put is null, so will return null. So next let's go with the get of 1 we have. So here we have 3 and 4, we have 3 and 4 in the cache, we don't have 1, we have deleted 1, right? So we have to return -1 in this case, we have to return -1 in this case. Let's move on with the last two get operations here. So get of, we have 3 is there, get of 3 is there, yes, we still have the 3 and 4 here, right? So we still have the this one 3 and 4 in the cache. So with the frequency 3 we have 3, right? So here we'll return 3 and we have 3 and 4. Next get of 4 is there, so yeah, we have 4 as well in the cache. So we will return the value 4, right? So this is how we got the output basically, that they have mentioned in the question. uh, 3 times null, 1 null, -1 3, null, -1 3 4. This part I'm speaking of, right? So this is how we got the output, right? I hope this part is completely clear, man, right? Along with the input, I hope this part is completely clear. Let's do one thing. The approach that we went with here is this one. What do we call? Doubly linked list. Doubly linked list, right? So doubly linked list. Just give me a second. Did I forget anything here? All right. Did I forget anything here? All right. Mm, 1 second. Yeah. We will be going with a doubly linked list basically. Also, as we are going with the key value pair, we'll be making use of the hash map, right? So we'll be making use of the hash map. I hope this part is completely clear. We'll be making use of the map along with the this one doubly linked list, right? So now, as we are completely familiar with the approach, let's quickly discuss the complexities and then let's write the code, right? So what will be the time complexity here? The time complexity would be big of 1. So why it will be big of 1 here? So as we have discussed this one already, we are making use of the doubly linked list, right? So average for get and put due to hash map and doubly linked list trick. So it will be big of 1. So in the question they have strictly mentioned that we have to write the code or the algorithm with big of 1 time, right? So the time complexity here for the get and put operations due to hash map and the doubly linked list trick would be big of 1. And what would be the space complexity here? The space complexity would be big of n here, n nothing but capacity, n nothing but capacity here, right? So capacity in the sense we have to store the key node map and the frequency list somewhere, right? So for that one, uh, for that purpose whole the space complexity remains big of n here, right? So the time complexity would be big of 1 for the code that we'll be writing in the future, and the space complexity would be big of 1, right? Big of n, sorry. Yeah, I hope the complexities part along with the approach is completely clear. As we are completely familiar with the approach and complexities, let's start writing the code. We are good to write the code. Let's start writing the code. First let's do one thing. So here let's go with the node class initially, because we have to represent each entry in the cache with key, also value and frequency frequency and pointers. These four things. Key value we know. We have to go with the key value. Also we need the frequency. So frequency of the this one particular number that helps in the get operation, right? So we have to go with the frequency and the pointers as well, so let's go with the node class initially. So I'll just go with here class node. This will be int key comma value comma frequency. So this is fine. Next, let's go with node previous comma next. So this is fine. Let me come out of this one. First, what shall we do? Let's go with the node here. This will be in k, the parameters k and the value, nothing but the key and value, right? So here, let's initialize key to variable k here, val to variable val, and also frequency initially. Let's initialize this one with 1, right? So I hope this is clear. Simple, right? So let's go with the doubly linked list. As I have said, we'll be making use of the doubly linked list, right? So why we'll be making use of the doubly linked list here? We need the nodes of the same frequency, right? We need to uh, within the get operation. So if you would have observed within the approach, while we discussed the approach within the get operation, so we need to evict, we need within the put operation to get the value. Next, to get the value within the put operation, basically, sorry, not the get operation, we need to evict the nodes based on the frequency if there is a tie, right? So in this case, doubly linked list will be handy. So let's go with the doubly linked list. So here I'll just go with class doubly linked list here. So this will be doubly linked list. So within this class, I'll just go with node head comma tail, node head comma tail. So this one will be size. Let's initialize the size to 0. Let's initialize the size to 0. Right. Let's go with the doubly linked list, right? Let's go with the doubly linked list, right? So here, this is fine. What are the things that we need to initialize here? Let's go with the dummy head and tail node. So here, dummy tail head and tail node will be very handy, man. Let's go with the dummy head and tail node. So just to simplify the edge cases, that's it. And also we have to connect the head to tail, and we have to connect tail back to the head. These four things we have to do within this one, right? So let's go with the dummy head node, nothing but we can try it in this way, new node of 0 comma 0. This is fine. And again, this time let's go with the dummy tail node, nothing but tail equals new node of this one, 0 comma 0. This is fine. So the next step is head dot next. Let's assign this one to tail. Next final step is we have to connect tail back to the head, nothing but tail uh, previous here, this one, let's assign this one to the head. So this is fine. Let's come out of this one entirely. Next we have to add the node to the front, right? So most recently used one, used among the same frequency. So we have to add the node to the front. Again, I'm stressing on it, we have to add the node to the front. For that one we have to write the code, means we have to go with the most recently used among the same frequency as per the approach, right? So whatever we discussed in the approach, same thing we are implementing in the form of code here. So let me go with void add parameter node here. This is fine. So within this one, let me go with node next equals this one. I'll just go with head dot next. This is fine. So let's go with head dot next equals node. Also node dot previous equals head. Node dot next equals next t. So this one will be next dot previous, this one equals node. Then finally we will increment the size. We'll increment the size. Means we are just adding the node to the front here. Nothing but most recently used among the same frequency accordingly with the approach. I hope this part is completely clear. Next, and also we have to do one thing, right? So if we are going with the put operation, then we have to remove a specific node from the list. We have to remove the specific node from the list based on the frequency itself, right? So based on the frequency itself. So here, mm, let me go with remove node. No, this is fine. So within this, I'll just go with node previous equals node dot previous. This is fine. Node variable next equals node dot this one will be next. This is fine. So here, hope this part is completely clear. The next part is previous dot next. This one, let me assign this one to the next here. Next dot previous here. Let me assign this one to previous. And as we are removing the node, let's decrement the size. Let's decrement the size. Here, one more thing we have to do, we have to remove the recently used node just before the tail. That also we have to do, right? For that one also, let's write the code here. Let me do one thing. Let's go with node. I'll just we have already made use of the this one remove, right? So I'll just go with the remove last here. So this is fine, the name remove last. So we are just removing the least recently used node just before the tail, right? So as we are making use of the linked list, so here this would be, let's write the simple if condition here. If size equals 0, then we have to return null in this case. We have to return null in this case. So this will be node last equals tail dot previous, right? So this is fine. So let's go with the remove of last. Let's make use of the remove operation. This one we have already written remove here. This is fine. So next, finally, let's return last. So I hope this part is clear. We are done with the remove last method. So this is fine. So next, what we have to do, we have to initialize certain things. So let's do one thing. So we will be going with capacity and the minimum frequency. So I'll just go with capacity, comma, minimum frequency variable names here. This is fine. And also we have previously discussed in the approach itself that we'll be making use of the map, right? So we have to map the key to the node. Also, we have to map the frequency to the list of nodes. These two things we have to do. First thing, let's map the key to the node. So I'll just make use of map here, integer, map integer. We have to map key to the node, right? So I'll just consider node here. This will be key map. This will be key map. Next thing is we have to map the frequency to the list of nodes here. In this case, map of integer, comma, doubly linked doubly linked list here. This is fine. This one will be frequency map. Frequency map. Just give me a second here. Yeah, we have successfully mapped the frequency to the list of nodes. This part is fine. Next, let's do one thing. Let's go with the LFU cache. LFU cache. Here we have the parameter capacity, right? So this is nothing but the initialization part. So let's initialize certain things. Here in this case, we have to go with the max capacity of the cache. So here in this case, it was given 2, right? In the example one, this one initialization. This is nothing but the max capacity of the cache. We have 2 for the example. So same thing. Let's go with here this dot capacity equals capacity. So this is fine. The next step is we have to go with the minimum frequency in the cache. Minimum frequency initially would be 0. So I'll just go with min frequency equals 0. The next step is we have to store all the key node pairs. Also, we have to map the frequency to its DLL, right? So here let's store all the key node pairs. For this one we'll be making use of the hash map. As I've said, I'll just go with key map equals new hash map. So this is fine. I hope this part is clear, man. Again, this time it would be frequency map equals new hash map. Frequency map equals new hash map. I hope this part is completely clear, man. Completely clear. Let's do one thing. Let's move on with the this one, get method. So just give me a second here. 1 second, man. Did I miss anything here? Hmm, 1 second. So we don't. 1 second. So here, before getting into the get method, so we will be making use of the this one update. What do we call this one? Yeah, update frequency helper method, right? So helper function. This one we'll be making use of it within the get method. So we have to update the frequency of the numbers that we have pushed using the put operation, right? So that's what we did in the approach. For that one, we will be step by step, we have to update the frequency of it, right? So for that, we'll be going with the helper function update frequency. So I'll just go with private void here, update frequency. This one will be node node. So this is fine. So within this update frequency method, so I'll just go with int old frequency. This one, let's assign this one to node dot frequency. This is fine. Nothing but we have to get the old frequency. After getting the old frequency, what we need to do here, we have to remove from the old frequency list here. This will be frequency map dot get here of old frequency. So I'll just go with dot remove of node. This is fine. So the next step is if the current list is empty and it was an minimum frequency list, then we have to increment the minimum frequency, right? So let's write the simple if condition for that. So if old frequency equals min frequency and this one, wait, this star here. This is fine. And frequency map dot get, we have to get the value of the old frequency, right? So this one will be old frequency dot size. If it is equal to 0, then we have to increment the minimum frequency. I'll just go with minimum frequency plus plus. So this is fine. Let's come to the final step here. So let's increment the nodes frequency as well. This will be node dot frequency plus plus. This is fine. And the final step here would be we have to add to the new list. Means in this case it would be frequency map dot this will be compute if absent. This one will be node dot frequency comma z. This is fine. uh, this will be new. Let's make use of the doubly linked list here. Let me come here. Let's go with the doubly linked list. So this one would be where it is. Yeah, here new doubly linked list. So this is fine. We are adding the node here, right? So we are adding the just node. We are adding this one to the new list, right? So this will be dot add of node. So this is fine. Uh, we are successful in writing the update frequency helper method or the helper function. Now let's make use of this one within the get method. So before using that, so let's go with the let's write the code step by step. First thing within the get method, so what we need to do accordingly with the question, so we have to get the value. right? So we have to get the value if the based on the key. If the value is not present, then we have to return -1, right? First, if key is not found, then we have to return -1. Let's write the code for that. Simple if condition base case. So this one will be key map dot contains key of this one key. Then what we need to do, we have to return -1. We have to return -1. Next step is we have to get the node from the map. So this one will be node equals key map key map uh, dot get of key. This is fine. Dot get of key. So then we have to update the frequency and the reposition, right? So for that one we have already written the update frequency helper function, right? So let me paste here update frequency of node. So this step what we are doing, basically we are just updating its frequency and the reposition. Finally, after doing that, we have to return the value, right? So the return value is integer, we know this one, right? Nothing but the value of the node here. So this one will be return node dot value. So this is it for the get method. Now let's move on with the, let me format this one once so that this looks good. Yeah, now let's move on with the put method. So within the put method, what shall we do? Just give me a second here. Did I miss anything? No, right? So within the put method, first step is let's go with the first edge case. This one. If the capacity is 0, then we don't have to do anything, right? So here on this case, I can write in this way. So if capacity equals 0, then we don't have to return anything. So the next step is simple if condition here. This would be if key map dot contains key of this one key. Then what shall we do? So within this one, if the key exists, then we have to update its value. So let's go with node here. This one key map dot get of key map of get of key. This is fine. So if the key exists, then we are updating its value. Next, let's assign the this one value of the node to value. Means I'll just go with node dot val equals val here. This is fine. So the next step, we have to update its frequency and the reposition, same as the get method. So I'll just go with the update frequency here. Update frequency of node. So this is fine, same as get method. So this is fine. Else what we need to do, else if it doesn't contain this one key map dot contains key doesn't contain the key, then what we need to do, if the key map, so here if let's write the simple if condition here. This will be if key map dot size here, if this one equals capacity, then what we need to do, within the if condition, if the cache is full, then we have to remove the least recently used with from the minimum frequency list. So I'll just go with the doubly linked list. So somewhere we have written the doubly linked list, right? So this class, just give me a second here. So let me do one thing here. Let me make this one capital D. So this is fine. This doesn't matter that much. 1 second. Did I do anything wrong? So this is fine. Uh, let's continue writing the code now. So where I have left, so here this will be doubly linked list. So we are going with the min list, right? So this will be frequency map dot get of minimum frequency. So this is fine. So the next step here would be we have to go with the least recently used on minimum frequency, nothing but node evict here. Let's assign this one to min list dot remove last, this one remove last. So this is fine. So remove last, for the remove last we have already written this one. Now this one we are making use of here, this one, right? Remove last. So let me remove this one. Double A. I had misspelled. This is fine. So in the next line, uh, so after going with the least recently used in the minimum frequency, we have to remove that one from the key map, right? So we have to remove that one from the key map. So I'll just go with key map dot remove here, key map of remove of evict dot key, of evict dot key. This is fine. So let me come out of this one entirely. So the next step is we are left with only one thing. We have to create a new node first. Then we have to store that one in the key map. Finally, add to the frequency equals one list. Then we have to add that one to the frequency equals one list. And then finally, we have to reset minimum frequency to one. Right. So these things we have to do. First, let's go step by step. Let's create the new node first. So here this one will be new node equals new node of key comma value. So based on the design problem, when it is given with the linked list, right? So this is the big headache, man. LRU is fine, but LFU is the extension of the LRU itself. So this is a big headache, to be frank. So after creating the new node, so we have to store in the key map. Means I'll just go with the key map dot put of this one. What do we call? Key comma new node. This is fine. So the next step would be we have to add to the frequency equals one less. So this will be frequency map dot compute here, compute if absent. So this one will be 1 comma set. So I'll just make use of the lambda expression here. This is fine. Just give me a second here. This one will be new doubly linked list. So what we are doing here, we are adding to the frequency equals one list, right? So I'll just go with add of new node. So this is it. We have successfully added to the frequency equals one less. So the final line here would be we have to reset the minimum frequency to one. Nothing but let's assign the minimum frequency to one. So this is fine, right? This is it for the code. So let me format the code once and let me hit the run button. I hope this works, man. Let's see. So we have the compiler error line number 77 within the local node.val equals val. Cannot find the symbol in LFU cache dot java variable val. So somewhere we have made use of the val, right? So just give me a second here. Val equals val we have given here within this one. We are in the put method, right? So here, oh, we are in the put method, not this one, right? So put method, what it consists of here? Oh yeah, here this one consists of the parameter value, not the val. So let me type this one entirely value. Let me run this one again. Yeah, you can clearly see here now the sample test case is getting passed, right? So let me hit the submit button quickly. So yeah, it consisted of the parameter value, the variable name. The parameter name is value, not the val. So that is the reason we were getting error. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities, right? So we have made use of the doubly linked list along with the hash map, to be frank, right? Doubly linked list, the custom doubly linked list we are going with here. You can clearly see the class doubly linked list, right? The custom doubly linked list, we have made use of the custom doubly linked list along with the hash map as we are going with the key value pair along with the hash map basically, right? So one more thing we have made use of to count the frequency or to update the frequency when it is required, we are making use of the update frequency helper method. So this is basically the design problem. Usually this one will be wouldn't be asked with the DS and day, so it should be asked in the system design interview, right? So this one and the previous problem as well, this one LRU cache as well. So I hope whatever the code that we have written is completely clear, right? Easy one. So I hope the solution part is completely clear along with the approach and complexities. For now, this is it. Thanks for watching, guys.